Today we are learning how to classify or categorize different types of numbers. And we categorize a lot of things. There's scientists whose entire job is classifying things. Okay, I'm not entirely sure about that, but I'm pretty sure I'm right. And there's a lot of different classifications. There's classification in language when you talk about pronouns and adjectives, you're classifying different words. Well, there are also different types of numbers. And we're going to skip these definitions where we classify, and we're going to go to this picture because I'm a visual learner. When you first learned how to count, you counted only with the numbers 1, 2, 3, 4, blah, 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 as high as you could go. Those are all called natural numbers, or some people just refer to them as the counting numbers. They are not all the numbers, right? They're just a select few. They're a very selective club, the natural numbers. Then our next club is just a tiny bit bigger. The whole numbers are the counting numbers plus 0. And I like to think that, I know that historically, civilizations didn't know 0 existed. Coming up with 0 was a big thing. So it was such a big thing that 0 gets to classify its own set. The whole numbers are the counting numbers plus 0. And in the past few years, you've learned about numbers called integers. Last year, you learned how to add integers and subtract integers and multiply and divide and do all operations with integers. They are the whole numbers plus negative whole numbers. So you take 1, 2, 3, 4, 5, blah, 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 2,000, blah, 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 3 million, and you make them all negative. Those are all integers, but they're not whole numbers or natural numbers. Now, maybe you can think of some numbers that I haven't mentioned yet. It's my favorite F word. Fractions. And the set of fractions we actually call rational numbers. And if you notice, rational has this word ratio in it, which is another word for fraction. So rational numbers are any number that can be written as a fraction. So you got your classics like 3/5. You also have any number that just can be written as two integers over each other. So 5/3 works too, even though it's improper. I also know that if we were to write 0.3, I could write that as 3/10, and that's a rational number. And I know that 1/3 is like 0.333333333. That is a rational number too. We're going to learn how to tell if something is rational because some numbers cannot be written as fractions. They are called irrational numbers, and that word means not. So these are things that are not rational and cannot be written as a fraction, and you actually know some already. The most famous one is pi. Pi goes on forever and does not repeat, and so people are fascinated with it. Another one was the square root of 2. This was actually one of the first irrational numbers that was discovered. And it doesn't repeat, doesn't terminate, which means to end. It's a very long, confusing looking number when you have it in decimal form. All of these numbers together, all the numbers that you have been dealing with your entire life, are called real numbers. And they're all numbers that you can point to on a spot on the number line and say, it's about there. Like pi, if we go 1, 2, 3 on our number line, we know that pi is about there. We can also find where 5/3 is. All of these numbers fit on a number line, and so they are called the real numbers. It is very important, you can follow along down here at the bottom, to note that a number can belong to more than one set of numbers. So let's take the number 1, for example. 1 is a natural number. It's in the most exclusive club. It also gets all the benefits of being a whole number. It is an integer, and it can be written as a fraction, so it's also rational too. So when you look at this diagram, anything that is in the very middle also counts in all the other categories. Then, irrational numbers, really those numbers are just irrational and real. And then every single number is a real number that you know of. So in the future, you will learn about more different types of numbers. For now, we're just dealing with those that are real that we can point to on the number line. Let's go ahead and write down these definitions so that we can remember what they mean. The natural numbers are the counting numbers. And go ahead and write some of your own examples of what counts as a natural number. You don't have to go in order. You can pick whatever your favorite numbers are that are counting numbers. The whole numbers are the natural numbers, including 0. You can go ahead and put your own examples. I would make sure to put 0 there just to make sure, because that's the only thing that makes the whole numbers different. The integers are the positive and negative whole numbers. So I always think of these ones as negative numbers, but they don't have to be negative. And 0 is included too. So make sure to have 0 and a negative number like 2 and a positive number like 45. Then remember, this is actually our most important definitions right here: rational and irrational. Rational numbers can be written as a ratio of two integers. In other words, we call it a fraction. Now, this part is very, very important, that they are integers. I've had students who try to prove to me that a number is a fraction by just putting it over 1, like 0.123 over 1. The problem is 0.123 is not an integer, so we need to find a way to make it an integer over another integer. And we'll talk more about how to do that, how to show that it is a rational number later. Go ahead and put your own examples of rational numbers. Just so you know, rational numbers can be written as decimals too, and they are decimals that terminate or end. Or they have a repeating, I don't like this word pattern, we're going to say set of digits. If it has 5 digits and it always repeats those 5 digits over and over and over again, then it is rational. If it has one that repeats, like 0.33333333, then it is repeating as well. Those are all rational numbers. So that's going to be super important for the future, that you know that a rational number will either end or terminate or repeat. Irrational numbers then are numbers that cannot, it's going to be the opposite of rational, cannot be written as a ratio of two integers. And they go on forever and never have a repeating set of digits. So it might be like a number repeats itself a couple times, but you can't write the whole number as a thing repeated. So we're going to look at our examples here. Remember, pi is like 3.1415, blah, blah, blah. E is 2.78 with a bunch of other random numbers that I don't know. Really, that's the thing, is it's going to look like when you look at these numbers, they'll frequently look like they are random. Most square roots, and that's what this name is called. So if you say, oh, it's the little check mark or whatever, that's called a square root, and most of them are irrational, but we'll talk about the rational examples in a bit. And then most cube roots. So a cube root is like a square root, but with a little 3 by it. And then remember that the real numbers are all of the rational and all the irrational together in one big set, one big happy family. So every number you have ever worked with is called a real number.